We're talking about absolute value graphs and quadratic graphs. So yesterday we talked about linear. Now we're talking about a couple others. So in this case, this graph, this isn't on your notes, this is just up here. X minus 4. I'm just going to have y equals x minus 4. Actually, let's talk about this real quick. It's not on your notes. Okay. Your book or IXL, sometimes they're going to write your equations like this. Right away, what we want to do is we want to turn that into two different equations. Okay, how I do that, I'm going to take the left side, I'm going to go y equals absolute value of x minus 4. So I just put y equal to the left side. Same thing with the right side, I'm going to put y equal to the right side. Okay, so all I did is I took them from one equation and made them two separate equations. Okay. Now we're going to do the same thing that we were doing yesterday. We're graphing both of those functions. Okay, which one do we know how to graph? The top one or the bottom one? We know how to graph the bottom one, right? And this one, it's already there for us. It's that line in there, that red line. Okay, let's talk about how to graph absolute values. Okay, on your margins somewhere in your notes, okay, I would make these notes. Absolute value. And remember, these are the ones with the absolute value bars. Okay. Absolute value, the graphs are going to look like, I'm going to draw the parent function. Remember when we talked about parent function, what does the function start at? 0, 0. Yep, so our parent function starts here. Absolute value graphs are always going to look like these. Okay, so absolute value graphs are always going to look like these. Up 1 over 1, up 1 over 1, like stair steps. Okay, going in each direction. Okay, if the absolute value is negative, if there's a negative in front of the absolute value, what do you think it does to the graph?
Makes it negative, like go down.
Yep, it's going to be an upside down V instead of an upright. Okay, that's what our absolute value is going to look like. Now, it's not always going to start in the center because notice it changes up here. Does everyone see that? Okay, so this one is if the absolute value is x. Okay, I should have put that in there. Okay, let's talk about the one up top. Remember we talked about that transformations, right, or transitions, where they goes left or right or up or down. Okay, this one's with the x, so is that changing the x or the y value? X. Changing the x. With the x's, can we think normally or do we have to think opposite?
Opposite.
We have to think opposite with x. So minus 4, we normally think left 4, but we want to go right 4. So that's why in this graph up here, it went right 4 from the origin. Okay, and then to get our other points, remember we just make a V, we go up 1 over 1 until you hit the end of your graph. Up 1 over 1 in both directions. Okay, looking at this graph up here now that they have both graphed, how many solutions are there? Again, solutions are where they cross. There's 2, right? There's one here and one here. How do we write our answers again? X and Y's, right? So, for example, one of them is 1, 1. The other one is 10, 6. Now, your book or some questions might ask, what is an X value? What's one of the X values? 1 or 10. What's the Y values? 1 or 6. So your book or IXL or some form might ask you what the specific values are instead of the coordinates. Does that make sense? Okay, so just remember with absolute value, it's always going to look like a V. Okay, look at part example 1. Look at example 1B. Should match this one that I have up here. Everyone see it? Okay, make your X and Y axis on your graph that they provided for you. Okay, what do I want you to do first with those equations? Split them apart. What is my first one? Y equals?
Negative absolute value of x minus 2.
Yep, negative absolute value of x minus 2. What is my second equation?
Y equals -1/2 x minus 2.
Yep. Let's think for a second. What is my red? So my red one's here. What is my red graph going to look like? a V, is it going to go up or is it going to go down?
Down.
Why?
Because it has a negative.
Yep, it has this negative in front of it, so we know our V is going to go down. Okay. Now again, remember our parent function starts where? Starts in the middle. Okay, but is that where ours is going to start? Right, we have that -2 in there. Okay, this -2 right here kind of throws it off. Which direction are we moving?
Right.
We are going right 2. Yep. Let me ask you this. If it had x minus 2, if it had a +2 there, what's moving? If it had a +2 on the outside, where would it go?
Up to.
It would go up 2, right? Okay, but since it's on the inside with the x, we're moving that x value. Okay, so again, think opposite. We're right here now. We moved right 2. Okay, how do I get the rest of my points for absolute value? Just go down 1 over 1, right? So down 1 over 1. Again, why am I going down? Why am I going down? Because it's negative, right? So go down 1 over 1 until you hit the end of your graph. Down 1 over 1.
Do we have to do points or can we just draw a line?
I would do points because you want them to be exact because of our solutions.
So do you want us to go up?
Nope. Why do we not go up?
Because it has a negative.
Because it's negative. So all of these are going to go down. Again, you want your points to be precise because of our solution in the end. Okay. Our blue one, how do I graph that one?
You start at -2.
Start at -2 on what axis? Y. And then where do I go from there? Down 1 over 2, go in all directions. What do you notice right away though? Right, do we already have a solution? How many solutions do we have on our graph? We have 1. Some people could argue, is there at some point going to be 2? Yes. Okay, but right now on our graph we only have 1. How do I write my solution? 0, -2. That would be my solution. Let's talk. If your book or IXL or something asked you what the x value is, what's the x value solution? So remember our coordinate here is xy. What's my x value solution? 0. What's my y value solution? -2. Yep. So moving on with quadratic functions. Quadratic functions, that's when we have an x squared. Okay, so what a quadratic function will look like, again, where do parent functions always start? In the middle. Okay, what these are going to look like is it's going to be a U shape going up. That's called a parabola. Okay. If it's negative, what's going to happen to it? It's going to go down. Okay. One more thing I want to talk about with quadratic functions is how you get your other point values. Okay. So your starting point, sometimes it'll look like this. If I have, not absolute value, sorry. If I have x squared minus 4, okay. This minus 4, is that the y or the x? Hint, if it was with the x, it would be written like this. So it's the y. So where is this at on the y-axis? Down 4. Good. If it was written in a form where it looks like x squared plus 6x plus 5, okay, we would do a totally different route. I want you to write this formula down. Say vertex. You're going to get that by x equals -b over 2a. Now, for example, I'm going to use that example I wrote up there. If I have x squared plus 6x plus 5, to get those a, b, and c values, this is your a, this is your b, this is your c. What is technically in front of that x squared right now? It's a 1, right? A positive 1. So the a, b, and c, those are the coefficients. Remember, coefficient is the number. Okay, so a is 1, b is 6, c is 5. Okay, so once you've found, we're going to do an example with this later, okay? But to find your x value to start, you would use this equation right here. And then to find your y, we would plug it in later, okay? One more thing to talk about with quadratic functions is the step pattern. Write this down. Step pattern. This is to get all your other points. Step pattern, you're going to follow 1, 3, 5, 7. What pattern do you notice? They're odd numbers. Okay, so when you get your, again, we're going to do an example with this. To get your other points, you're going to go over 1, up 1. Then you're going to go over 1, up 3, over 1, up 5. And then you're going to do it the other way. Over 1, up 1, over 1, up 3, over 1, up 5. Yep, so you're going to follow this step pattern to get your other points.
Okay, I'm gonna use 7.
If your graph is big enough, yes. Yep. So if your graph was big enough, what would be after 7? 9. Yep.
Use the bottom one.
Yep, if your graph is ever big enough. Yep. Again, we will go do an example over this. That's just a brief overview of what we'll see with quadratic equations.
There's so much.
Okay, I know there's a lot more. Let's look at this example that they have right here, though. I'm going to change it a little bit. This is not in your notes. Okay, I'm going to change it just a little. 5x squared minus 4 equals 1. Again, I want to write two different equations. What's my first equation? Y equals,
Negative.
I want that left side. Y equals x squared minus 4.
4.
And then what's my right side?
Y equals 1.
Y equals 1. Okay, let's talk about this y equals 1 first. Where's y at, or sorry, where's 1 on the y-axis?
1 on the x-axis to the right
1
1.
on the y-axis, sorry.
Up 1.
Up 1. If that's the only y value I want to hit, is my line going to be this way, or is it going to be this way? If that's the only y value I want to hit,
Straight up and down.
it's going to be this way. Let me explain why. If I went straight up and down, is that the only y value I'm hitting? No, that's why I want to go this way.
What's the x way though?
Okay. Now talking about how we graph this equation right here. Again, is this minus 4, is it with or without the x? Without, so it's the y value. Where does that start if it's minus 4 for y?
On the negative.
Down 4, right? We're starting here. And then step pattern, we go over 1, up 1 first, and then over 1, up 3, over 1, up 5. Yep. How do I get the other side?
Same pattern.
Same thing, over 1, up
3. 1.
1, over 1, up 3, over 1, up
5.
5. Yep, and then you would draw your parabola there. Your solutions are still the same as what they were before, where they cross. So in this case, they crossed here, and they cross here. Okay, so same idea, we're just graphing a different type of equation. Yes? Okay, let's look at example 2. Go ahead and draw on both of those graphs, example 2, draw your x and y axis on both of those. I'm on example 2b, I changed the equations to this one. We're going to go back to A, I want to do this one first. Okay?
Is this a quadrant? Right?
Yep. So what do I want you to do first with those? Split them. So if I write y equals, what's my first one? X squared minus 2, and then y equals 1/2 x plus 2. Okay? Again, you have a graph. Go graph that line that we're used to. Go graph that second equation. Yep. Okay, again, start it. Positive 2 on which axis? The y-axis. And then where do I go from here? Up 1, over 2. Fill your whole graph as far as you can go. In both directions. And then draw your line. That is my first function. Again, your graph will look better on yours. That is my first function. Now this second function, okay, is it going to start at 0? No, because it's changing just a little bit. Okay, what does that minus 2 mean? Is it the x or the y? It's the y. So where do I go? down 2. Yep, we're starting here. What pattern am I using? Are we doing a V? Or are we doing a U? We're doing a U, so what pattern is that? Step pattern. So over 1, up. Careful.
Over 1 up 1.
Over 1, up 1. And then over 1, up 3. Over 1, up.
7.
Our next one will be 5. Did you fall off the graph? Okay. And then go the other direction. Over 1, up 1. Over 1, up 3. Over 1. Did you fall off the graph again? Okay. Draw your picture. How many solutions do we have? 2. I have 1 here. I have 1 here. Are they clean solutions on your graph?
Kind of. Not much.
They're not clean. Okay, let's pretend this one is. This one, I'm going to say that one falls at 2, 3. Okay. 2, 3. If you ever do this on a worksheet or IXLs or anything, they will be clean solutions. Okay, I just made these up off the fly so they're not precise.
So we're only using step pattern when we're using the y equals x, x squared.
Yep. Yep. So if we say our solution is 2, 3, and then there's also this one, right? Okay, let's do that. -2, 1. If a test or IXL asked you for the x values, what would my solution be? X equals -2 and 2. Okay, what if it asked you for the y values? 1 and 3. Okay, so just be careful what IXL specifically wants for the solutions. Okay, most of the time they're going to want these ordered pairs. Okay? We're going to do A. But ignore the inequality, change it to an equal sign. We're going to get to inequalities next week. So I have x squared plus 6x plus 5 equals 0. Make sure you have your x and y axis drawn. So it's always where the equal sign is. So my first equation is going to be what? X squared plus 6x plus 5. All of that is one equation.
Oh, that's one.
Yep.
And that's the one I'm using the step pattern.
And then the other side is y equals 0. Okay. Now, looking at that quadratic function, my red one, is that one as simple to start as the one we had before? No, because we have 3 terms now. Okay. We're going to use that vertex form that I just gave you, which means we're going to use x equals -b over 2a. Now let's label some things. What's my a value? Remember, we want the coefficient. 1. Remember, we want the number in front. What's my b? 6. C? 5. Good. So let's plug it into this equation here. What's my -b? B is 6, so what's negative of 6? -6, yep. And then 2, my a value is 1. -6 on top, 2 times 1? 2, so -6 divided by 2? -3. Now, that's my x value. Can we graph an x value without a y value? You could, okay, but we need a y value to get our starting point. Does that make sense? So our y value will not be 0 because, notice here, our equation is equal to y. That's for the other equation, but we're just dealing with this one first. Yep. So for this equation, we are going to plug in our x into this equation here to find out what our y is. Okay, so let's do that. I have y equals -3 squared. Whenever you plug a number in, put it in parentheses so you can see it better. -3 squared plus 6. Is it 6 minus 3? Nope. 6 times -3. And then we have plus 5. So now we just have to simplify. What's -3 squared? 9. 6 times negative 3, negative 18 plus 5. Then you just type that in your calculator. 9 minus 18 plus 5, which gives you a negative 4. So now we have an x and a y value. How do we write a coordinate?
Oh, that's all just for one.
That's just for our starting point.
-3,
-3, -4. That is our starting point for our parabola, or our U shape. Okay, so go ahead and graph that on your paper. And then how do we get all the other points? Yep.
So where do we start at? -3?
So find -3, -4 on your paper, which mine is here, roughly. Now, step pattern from this point. So we go, first of all, is our parabola up or is it down?
Down. Up.
Yep, because there's not a negative in front of here. Okay, so our pattern is going to go up. So we go over 1, up. Nope, don't skip the 1.
1.
Over 1, up 1. Over 1, up 3. Over 1, up 5. Did you run out of room?
Yep.
Okay, go back. Over 1, up 1. Over 1, up 3. Did you run out of room? Yes. Let's draw your picture. Okay. What was my other equation from the beginning?
0.
What about 0? Y equals 0. Where is 0 at on the y-axis? In the middle, right? If that's the only y value I want to touch, which way does my line have to go? Has to go this way, right? So our line happens to be on the x-axis. How many solutions do I have? 2. Circle them. How do I write those as answers? -1, -0. I like it. What else? -5, -0. Good. If it asks for the x values, what are my solutions? -1, -5. If it asks for my y solutions, 0. Yep. So again, this is our whole goal that we're trying to get to, is where the two lines cross. Okay?